morning, chemistry students. So this is our last class, and what we're going to talk about is possibly the most fun thing. Because last week we talked about electrochemical cells, and that's just when something rusts, when something oxidizes, when you take a standard equation and you just see the single replacement reaction. But sometimes you've got something simple, like sodium chloride, and technically it's made of sodium and chlorine. We're just going to kind of balance that up a little bit. But it's not something that happens all by itself. Technically, if we assign some oxidation numbers here, +1, -1, here it's all by itself, so it's going to be 0, and the chlorine's all by itself, so it's going to be 0. So it seems like our sodium ions, we've got 2 of them, should become sodium atoms. And our chlorine ions, we've got 2 of them, should become one little diatomic chlorine. Now this one is going to need to take in electrons. And this one, if you've got 2 negative things and they become 0, it's also going to have to give off electrons. This seems reasonable. It seems like something that could happen. A little bit of review. If it's taking in electrons, then that is going to be called reduction because the oxidation number decreased. Down here, our oxidation number increased, so that's going to be oxidation. So here's oxidation, here's reduction. This seems like a standard redox reaction. However, we know that sodium chloride doesn't do this. It doesn't just break into sodium and chlorine. It actually breaks into ions. You put it in water. It breaks into Na pluses and Cl minuses. How could we get it to actually make sodium and chlorine? I mean, this is explosive in water. This is a toxic gas. I want to get these things. How can I do it? This is how you make chemistry happen that doesn't want to happen on its own. So let me show you how to do that. What you need is a container and you need a liquid. This liquid needs to have the sodium chloride in it. Right? And you don't need specific electrodes like you do in electrochemical cells. You just need any 2 electrodes. Okay, so any 2 pieces of metal, and you've got your sodium chloride floating around in here. What's going to happen is instead of putting a voltmeter here, we're going to actually attach a battery. We are going to electrocute this thing, shoot the electricity into this thing. And when that happens, if this side's the positive side and this side's the negative side, then the little Na ions are going to migrate over here, the little Cl ions are going to migrate over here, and they're actually going to get the electrons that they wanted and give the electrons that they wanted, and they're actually going to start to form these products. So the trick, these products. The trick to getting things that science to happen that, wouldn't happen on its own is to use electrolysis, which is getting 2 electrodes, the container, and electrocuting it. Are you ready to see that happen? So, what I need is a source of salt. A pickle. Nice thing about a pickle is it comes with its very own container. So, here's my container of salt. And I need 2 electrodes. There I have 2 giant nails that I can use as electrodes. So I am going to put those on there. And then all I need to do is electrocute it. So I have attached my wires. These are connected underneath just to the nails. So all I need to do is plug this thing in. Notice I'm at school, not at my house, just in case, So I need to plug this in, and we'll see if I can make sodium and chlorine occur. Oh, we got bubbles happening over on this side. There's also a little bit of bubbles over here. How do we know which side is chlorine and which side is sodium? We're definitely doing something. So in electrolysis, the anode is where the oxidation occurs. So that's going to be the chlorine side. The anode is where the oxidation occurs. In this case, it's going to be negative. The anode is going to be positive in electrolysis. I really like electrolysis. The anode is positive. The cats are finally negative. All year cats have been positive, but in electrolysis, the cats are finally negative. There it is. There it is. I know which side the sodium's happening on. Because when sodium forms, it's explosive in water. So as soon as it forms, it shoots off little electricity. I'm going to turn off the lights so you can see it a little better. There we go. There's nothing quite like electrolysis. All right, I hope you'd enjoyed this little explanation of electrolysis, making chemistry happen that didn't want to happen on its own. Hi, chemistry students. I wanted to say something to you about this year. I haven't really gotten to teach everything that I wanted to teach. I hope that you're prepared enough to understand chemistry a little bit as far as, the rest of your life is concerned. But more importantly, I just want to encourage you all to take physics next year, to make sure you get some of the information that you've missed, but also to prepare you a little bit more. I really missed teaching all of you. I do want to see you on Thursday, but the school parade is also on Thursday, so it'll be a really short class. And I miss you all, and I hope that you have a good summer, that you're safe, that I do get to see you every now and then. Please continue to keep in touch with me to let me know that you're okay. And I really, really look forward to seeing everyone next year. So please take physics, stop by, say hello, wave to me whenever you see me, and have a great summer.